Ordinarily, you would come into the Sims lab, the front of the Chambers building. There's our Sims lab with all the windows. And pipe in. So as you're coming through the door to the lab, ordinarily the machine would be turned on and ready for you. There's a power switch on the back, main breaker, air supply down here. The machine will be dark. And we'll come over to the pendant here and go ahead and hit the power on. So we'll give that a moment to boot up. And the first thing it's going to show is a series of alarms. So we have the e-stop needs to be re-engaged, and the doors need to be cycled open and closed. And then we'll go ahead and reset our alarms twice. And now the screen is clear, no alarms. At this point, if everything is clear and out of the machine, we can do a power-up restart, and it'll bring the spindle to home and lock the table in the lower left corner here, the machine home position. If the machine hasn't been running for a while, it will need to do a spindle warm-up routine. The machine will spend about 5 or 10 minutes at a series of speeds, ever increasing speeds, starting at, I guess we'll find out here in a minute. 500, we can see M3 S500. So it'll start at 500, and then I think it runs all up to about 7,500 RPM. And that makes sure that the spindle is lubricated and warmed up and so forth, and we're ready for running our machine. So the first thing we're going to do, we'll make sure that everything is clear, there's no tool in the spindle. To list program. So program 2020 here is our spindle warm-up routine. We'll go ahead and select that program, and then we go to memory. This is the program that's loaded in memory right now. And we can look at our G code here. These are all notes here, so if it's in parentheses, it's notes. So starting with S500s, spindle speed 500, M3, turn on your spindle in clockwise rotation. And then we're going to dwell at that, and then we're going to continue to increase that speed up to about 7,500 RPM. All right, so we can go ahead and hit cycle start. And we can see in there our spindle has started spinning at about 500 RPM. And this whole process takes about 20 minutes. So while this is getting ready, warming up the machine, if it isn't already when you come in, this is when you can prepare things on the bench, get your programs ready, go grab a cup of coffee, etc. So once you've prepared your tool paths, you've done your simulation, everything looks good, we need to consider the work coordinate system that you've chosen for your tool paths. In this case, I've chosen the center of a cylindrically stock part. So what we'll do is export our NC code, and then we'll have to go set up our stock on the machine in that same configuration. So let's go ahead and export that code, and then we'll take that over to the machine and we'll set up our stock. So I put my NC code onto a flash drive, and we bring this over to the pendant. We insert this on the side about like this. We're going to need to go to list programs. And then in this case, we need to go over to our USB device. So this lists what's on our USB device. Go over to that window, go down. My part is called Totem 1. And we select the program. And it automatically puts it up into memory. So our tool number 6 is a 0.1875 end mill, and our tool number 8 is an 1/8 inch end mill. So I'll go over to the turret here. All right, so what I'll do is confirm that my tools are in the right position. So number 8 is an 1/8 inch end mill, and number 6 is a 3/16 end mill. So that looks good. Now we need to load up our stock part. All right, so I have my aluminum cylinder that we'll cut the part from. I've got a V block and some parallels. So we're going to place our parallel bar, our V-block, and our stock material. Tighten that down. And now we'll want to go ahead and switch our tool to our edge finder. In this case, it's tool number 2. So we go over to our MDI. We have to close our doors. And we'll hit tool 2, ATC forward. Okay, now we can open the doors back up, and now we're going to run our edge finder like we would on a regular mill. So I can type in, let's say 500 and clockwise, and that turns our spindle on in the clockwise direction. Now we go over to hand jog. Make sure you start off in the 0.001 increments, make sure you've got everything figured out. So then we can advance to 0.01. So I'm in the Z, I can bring our spindle down. So we push the X button and we can jog this over. And we'll go in the Y direction. And we bring our Y forward, and we're going to want to touch off on the back side of the jaw for our vise. Let's go ahead and give ourselves a little more room. And Z. We bring Z down. Carefully. Get a little more room in our Y here. And we're going to switch to 0.001 increment. And we'll take this right up until we touch off with our edge finder. There we go, right there. Okay. So now we hit offset. This is our part 0 set. So press offset again. We need to change our G54 value. So we use our arrow keys to come down. In this case, I'm changing the Y value to begin with. So here we go ahead and put part 0 set. All right, so after we found our Y coordinate on the back of the vise, we're going to bring the X over past the edge of our part. And we're going to set our Y by moving. So we have our edge finder is reading 0.1 to the inside of our actual part. So we want to move our Y axis to the outside of that. So we're going to increase it by 0.1. Right there. And then we're going to go ahead and re-zero our part. Now we're going to dial that forward 0.75 inches. And that should put us exactly halfway to the inside of our part. We're going to come down in the Z. And I'm going to tap off on our edge finder there so we've got some wobble. Z height looks good. So now we're going to jog in the X direction. And as I start getting closer, I change to a smaller increment. Right about there. So part 0 set in the X direction. I'm going to hand jog up to Z. And then I'm going to now move in the 0.1 of our edge finder to 0.1 on our X there. And one more time I'm going to zero out the X with the part 0 set. I'm going to move our X 0.75 and 0 on that. So if we look on our display over here for our work coordinate system, our X is at 0, our Y is at 0, and our Z needs to be set for each individual tool that we'd be running on here. So we'll go over to our tool offset next. So we'll need to change tool 6 and tool 8 to be the correct for the top of our surface here. So I'm going to go ahead and stop our spindle, close the doors. Tool changes need to be done with the doors closed. I need to be in MDI mode. So I'm going to move over to tool 6 so I can type T6, ATC forward. All right, so we're going to go back to hand jog, 0.01 in the Z direction. And we're going to bring this down. Now my part actually has a little tiny burr that's sitting up above there. So I'm going to move this forward of that burr there. And then back to the Z, and then we'll move over to the 0.001. And I'm going to get down fairly close. I'm going to grab a piece of paper. I'm going to come down and I'm going to jog the wheel down while I start feeling for drag under this piece of paper. Slowly, this is 1/1000th of an inch at a time, each click of the wheel, and it's just touching down, just a little bit of drag on there. Okay, so that's our Z for that tool. So I go over to offset, we make sure that we're on tool 6, and here we hit the tool offset measurement, -9.999. That's a coincidence. All right, so back to hand jog, Z, 0.01 in the plus direction. Get that up and clear. And we're going to change over to our 1/8 inch tool bit. So again, I'm in MDI mode. I want tool 8, and we'll move the carousel forward. Okay, we have our 1/8 inch end mill in there. And we go to hand jog, 0.01 in the Z direction. Roll this down. We're relatively close. Switch to 0.01. Grab our highly precise piece of paper here. And we will jog that down until we just start feeling that drag again. Right there. Okay. Go to offset. Tool offset. We need to jog down, make sure we're in spot number 8. And we'll hit tool offset measurement. 10.059. Okay. Hand jog. Z, I like to move our spindle up there. Get that up and out of the way. Okay, we've put our program into memory. We've put our part into the vise. We've zeroed the part work coordinate system right over the very center of our cylinder. At the top of the surface, we have zeroed each of our tools that will be used in cutting. Now it's time to go ahead and bring the program up. So we can go back to memory. This is our totem 1. We're going to use a mist coolant. A little bit of coolant in there. All right. Now we want to put our rapids at 5%, and we want to switch over to single block. Single block makes it so that we have to give it the machine an input each time it gets to a new line of code, and then it gives us a chance to start and stop as we go. And then also at 5% rapid, that makes sure that in the non-cutting moves, it saves us from smashing into something faster than we can react with the buttons and so forth. So I'm going to go ahead and hit cycle start. So it's going to run down through each one. So these are the comment lines up here. So our first real line of code is N60, G17, G40. And I'm going to be right here on the feed hold button. 6M6. So it's going to switch over to tool 6. It's moving nice and slow with those 5% rapids. We'll go 25%. We'll leave it at 5%. Okay, next line. We are at 8,000 RPM. Brings our table forward. So this is our 5% rapid coming down. All right, next line. Here we go. So it's Each curve, each part is a new line of code, so I'm going to go ahead and turn off single block and hit cycle start, but have my hand on the feed stop just in case. Okay, I'm going to stop right there. My bit's not in the tool. I'm going to open the door and this will slow the spindle down to 750. The only reason I'm doing this is to double check to make sure that our camera is actually catching all of this. Alright, so now we can go back to cycle start again. Spindle goes back up to full speed. And then we are cutting the next part. Here you can see that the display, hopefully you can see on the display here. It's just running through each line of G code there. So my toolpath has a roughing run with a 3/16 end mill to clear most of it, all but 5/1000ths of an inch, and then it'll come back through with our 1/8 inch end mill and do a finishing pass with that. The step down on this is 50/1000ths of an inch. With full flood coolant and stuff, you can usually go with a step down that's about half the diameter of your drill bit or your end mill. In this case, with the mist coolant, we want to take a little lighter cuts. Now we should be switching over to that 1/8 inch end mill. That's running at 5,000 RPM. Ooh, I should have slowed that down just a little bit. There, so we're running at 20 inches a minute. Beautiful. To remove the part, it's actually a good idea. We've got a little air blaster here. Keep the doors mostly closed. Stick just your arm in. And blow it all down. And make this a little bit easier, we will hand jog our Y towards us a little bit. No, we were getting a nice finish on there. Everything was running just fine. It's pretty nice.